I'm going to move it, okay, I don't care about that. We're going to move at a decent pace today, just nothing too bad. If I get moving too fast, let me know. Now, this seems kind of odd. We're jumping from sets to intervals, bounded and unbounded intervals. It seems like a weird jump, a weird transition. Now, the reason we do this is because when we start talking about sets, and sets that we cannot easily write, that cannot even, we A, can't list all the terms nicely, or B, we can't make a pattern, we need a way to describe it. And inequalities, especially with real numbers, is the easiest way to describe a group of numbers that we can't just write. Now, there's two types of intervals, bounded and unbounded. So, bounded intervals are specified by having two specific endpoints. They have a start and end to them. There's two places that we don't go past. Now, we have all these words on this page. Let A and B be two real numbers such that A is less than B. Then A and B are the endpoints of four different bounded intervals on the real number line. Now, it does seem like a lot of words, and it's like, okay, why do they phrase it this way? Why did I type this up this way? And it's for a specific purpose. And the nice thing with this is by using A and B, not actual numbers, all we're saying is that A and B could be any number we want, any real number. And as long as A, whatever we pick, is less than B, we will get one of these four sets. And it doesn't matter what A and B are, as long as A is smaller. Because if this is true, all four of these are true. It gives us a way to classify every possible bounded interval in four statements, which I think is really nice. And I think for the most part, y'all know how, I've seen these before, we've done these before, yes? Bounded intervals, unbounded interval, or bounded intervals. It's either both endpoints are going to be included, or they're not. Or we're going to include one and not the other. If the endpoint is included, especially in interval notation, we use brackets. If the endpoint is not included, it's not equal to whatever that endpoint's value is, we use a parenthesis. Inequalities will always have a variable. Normally, we're just going to use x. X is greater than, x is less than. We have variables when we talk about inequalities. We have it in the statement. We're just saying this number is going to have to be bigger than it. All numbers are going to be bigger than it, smaller than it, greater than or equal to, less than or equal to. When we talk about it in interval notation, we're saying these are the endpoints for bounded. We want everything in between. And then we determine if the endpoints are included or not, based off the brackets or parentheses. Now, the other set that we have is unbounded intervals. Let A be a real number. So we're just saying one of the endpoints, because unbounded does not have two. It just has one. It's going to start here, and it's either going to go to positive infinity or negative infinity based off of the symbol of the inequality or the graph. And again, we have four main types. We're saying that x is greater than or equal to a, or x is greater than a, so bracket a comma infinity, parentheses a comma infinity. Or it could be less than, parentheses negative infinity comma a, bracket, or parentheses negative infinity comma a parentheses. Now, I do always include the case where it's just the whole number line. In interval notation, it's just negative infinity comma infinity. Luckily, y'all aren't having to fill in the number lines. Yep. And a great way or easy way, I don't know if y'all have heard, to do infinity is just to turn the paper sideways, draw an 8. Any questions on any of this here? I'm going to figure out which one of that's in that spot. Fix that. That's going to get frustrating. Everything. That's going to be all year staring in the sun. Any questions over bounded or unbounded? So the first thing we're going to do, especially with that on that page, is writing interval notation. Interval notation is using our parentheses and brackets and talking about our endpoints. Interval notation does not have variables. We won't have x written in a interval notation. So our first one's -2 is less than or equal to x is less than or equal to 3. How would we write this in interval notation? Y'all remember? Because this might have been a minute, yes? Okay, so there's different ways to come at it. One of the main ways I look at it is with bounded intervals, we have endpoints. With interval notation, we're talking about where is it starting, where is it ending? Where are the endpoints, is what it's telling us. And what are our endpoints on A? There are? Well, they gave us 2 of them, yes? -2 and 3. So we're saying we want all the points for certain between -2 and 3. So I know one of the 2 numbers listed is going to be -2 and the other has to be 3. Because when we do this interval notation, we're saying we want the numbers between here and here, or starting here and going here, going towards this side. Since this is bounded, because x is in the middle, we're going from here to here. We're saying it's starting at -2 and going to 3. Smaller on the left, bigger on the right. Questions on how we got these 2 numbers or set this up so far? Now we need to determine if those are included or not. So when we look back at the problem, we need to see, is -2 equal to x? Is it included? Do we have an equal sign here? Well, yes. So that means -2 is included, so we have to put a bracket. If it was just less than x, we would put a parenthesis. Now we're going to do the same thing with 3. We're going to look at its inequality sign. Does it have, or is it saying it's equal? X is indeed equal to 3, so we'd also have a bracket. Because we're saying -2 is less than or equal to x. Is less than or equal to 3. So in this case, x could be -2 and x could be 3. Then it would make that statement true. So we have to include those points. If it was just -2 is less than x is less than 3, we don't have that equal line underneath it, we would have used 2 parentheses. Does this make sense? The other way we could have done this is, I'm going to go back over here. I'm going to rewrite it. You don't have to write it here. -2 is less than or equal to x is less than or equal to 3, yes? Out of these 4, what's inequality does this match up to? The top one, yes? But instead of having A, we have -2, and instead of B, we have 3, yes? Which means here, this A is going to be what? And this B is going to be, I'm not changing anything else, I'm just putting those in place of it, yes? Which means I can come over here and say, this is supposed to be -2, this is supposed to be 3. This chart seems a lot more helpful now, doesn't it? Because again, these 4 things are all bounded intervals with a given value for A and B. That means for any bounded interval, I can jump back here, plug in, see what matches with A, what matches with B, and I get all of it. Do y'all want to keep using this for each one? Or using these charts? Yeah, that's fine. because it asks for the interval. We got it. Let's use the chart for the next one. X is greater than -1. Is it bounded or unbounded? Unbounded, because we only have one endpoint, yes? I'm going to come over here for our unbounded. X is greater than -1. I'm just going to write it up here so we're not jumping between the two slides. Which of these four does it match up with? Second one. So what we're saying is that A is what? -1, which means I can come down here and replace A with, which is telling me I have -1 comma infinity. It is going to be parentheses on both because -1 is not included. It's not greater than or equal to it. So we wouldn't put a bracket there. And infinity will never have a bracket next to it. It's always going to be a parentheses with infinity. And we're talking about greater than. X is going to be bigger, so we want to get bigger numbers than -1. Now, another thing you can do to always make sure it works is what I call a check method, or just verifying. So we're saying we want numbers from -1 to infinity, yes? What's a number between -1 and infinity? Any number. Is -2 greater than -1? No. And luckily, -2 is smaller. So let's instead say 2. Is 2 greater than -1? Yeah. And it is considered to be within this here. And the reason I bring this up, and especially a lot of what we do on, say, the ACT, because ACT does give you, some of the times, they will give you an inequality like the two we just had, and then a graph, which of the following is the correct graph for that inequality. We know whatever the shaded region, those numbers have to be included in the answer. So it's telling me the blue shaded part is the answer. Those numbers satisfy or make the statement true. So if I wanted to figure out which graph it was, I could pick one of those numbers, plug it in to the original inequality, and see, does this make it true? Is it a true statement? If it does, it is the correct answer. If it doesn't, it's not. We throw it out. And we'll see more of that as we go through the year. All right. Let's look at C. -3 is one of the endpoints and 4 is the other. We are bounded, yes? Well, we can't use the chart because it only gave us intervals and inequalities, yes? I gave you graphs too, didn't I? Which one of these 4 is it? Yeah, unfortunately 4 is not included. So the third one, A is -3 and B has been replaced by 4, yes? Which means for our interval, A is going to be -3 and B is 4. Now, since A, the point at A was included, it would need a bracket. Like it says here, since B was an open circle, it would be a parenthesis. Funny enough, I can come over here and say, replace A with -3, B with 4. That chart literally gave us all 3. That's why this is nice. Now you're probably thinking, well, we're not going to have that on the test. Remember, you can use your review sheet on my tests. So if you want to go through and add that to the review sheet, go for it. D, bounded or unbounded? Unbounded. We'll look at the chart here in a second. Our one endpoint is 3, yes? So we know it's going to be included in interval notation. Are we getting bigger or smaller? Smaller, so that means we're either going to go to negative infinity or positive. We're getting bigger negative, so we have to go to negative infinity. Smaller numbers on the left, bigger numbers on the right. Negative infinity always has a parenthesis. Is the 3 included? Bracket. So parentheses, negative infinity, comma, 3 bracket. Because it feels like, especially when you guys did this the first time, it feels like there's some tricky thing going on. It's, for the most part, when we talk about interval notation, what are we seeing? What numbers are included? Well, we're going from negative infinity, really, really, really small numbers, really big negative numbers, all the way to 3. And we're including 3. We just described this as an interval, as 2 numbers. Are we ready for the next part? Now, set builder notation, I normally do kind of a big lead up to it. This is going to seem more complicated than it actually is. What this is a way for us to describe any and all sets in a succinct form, a nicer form. Likely you will not see this again after this chapter. You might see it referenced or talked about, but you are not actually going to have to write it. Now, the triangle, what goes in place of the triangle is what is our group? What types of numbers are we talking about? Are we talking about the real numbers, the natural numbers, the integers, the rational, the irrational? What is our group of numbers we're referring to? And the circle side is our description. X is greater than 2. X is less than or equal to 3 are inequalities. Now, it doesn't just have to be inequalities. It can be words. X is even. X is odd. X is a prime number. X is not equal to 3. We can have anything we want there. It describes it. And funny enough, that bar in the middle means such that. Our given variable is this type of group or these types of numbers such that follows this description. Well, that doesn't make sense, especially since we have nothing to connect it to. So let's actually look at a few. So if we notice the first part, our group of numbers, what numbers we're describing, it just says X. Whenever X is by itself, it's just brace X or brace X bar. We're talking about the set of all real numbers. If a number type, set, or group is not described, it is assumed to be all real numbers. It is understood to be all real numbers. So brace X bar is saying the set of all real numbers X, or X is contained within the real numbers, such that we give a description for it. X is less than A. Graphically, what we're saying is that at some point on the number line A, we have this point. Now, it's not equal to it, but we want all the points, all the numbers, less than it. So graphically, this is all it's saying. The set of all real numbers X such that X is less than A, so all the points less than A. Yeah, it could be 7, so we're saying all the points, or all the numbers less than 7. That's it. Or the second one, the set of all real numbers X, brace X bar, such that, set of all real numbers such that X is not equal to 3. Well, let's put the one number they did tell us. Well, we know it's not 3, but it's saying it could be any other number, yes? So could it be bigger than 3? Could it be smaller than 3? I will tell you this, especially when we write interval or set builder notation with inequalities or from a numerical graph like this here, except for the second one, we're going to be using all real numbers. Unless it tells us otherwise, for the most part, we're assuming it's all real numbers. I think we're kind of getting the hang of that. We'll see a bit more. I want to jump down to this last one, or not last one, the fourth one. Because we get this E. Whenever we have this, I put this in, the book doesn't do this. Mainly because that E means element. It's a part of it. It's a part of that set. Now, if you notice that there is no symbol next to it. Yes? So let's put a Z with a bar for this one here. I don't know if he's in the door or where he's at. Yeah, he's behind that bookshelf. Yeah. Hopefully moves. Hopefully it'll quit. So by doing that, we are saying X is an element of the integers. We're giving it a group name. So instead of saying all real numbers, we're just saying integers. So only the integers. So the only values of X that we will have are the integers, and we're saying they're less than or equal to 9. Yeah, that's getting funny. They're always bad this time of year. You're good? They left it. Questions on any of this? No? So let's look at actually sketching some of these graphs and seeing how this works. So the first one, A, the set of all real numbers X such that 2 is less than X is less than or equal to 5. Funny enough, we want to sketch this graph. This is just saying we're using the entire number line. So really it's just saying sketch this. So since this is bounded.
May I have your attention? May I have your attention, please? I need following students to go to Ms. Kilgore's room, Abraham, Lacey Boulder, Easton Shelley, Jenna Simmons, and Simon Haggard. Thank you.
Since it's bounded, we have 2 endpoints, and it's going to be everything in the middle. Now we just need to figure out if the endpoints are included or not. If neither endpoint is included, we're done. Because if they're not included, we leave them open. Is 2 included in this inequality? Do we have that equal sign on 2? No, so it's going to be left open. How about 5? Yes. Means we come and fill 5 in. That's it. Because 2 is less than X is less than or equal to 5. Because with inequalities, when we have that line underneath it, it's saying equal to. It's less than or equal to it. But that's all we have to do there. B, again, brace X bar, the set of all real numbers such that X is less than or equal to 0 or X is greater than 4. This one here is a compound inequality. We have 2 different statements. Both of them are unbounded. So they have one endpoint and continue on forever. With or statements, we'll do it one at a time. We can do the first one here. X is less than or equal to 0. So where's our endpoint? 0. Is it included? Yeah, so it's equal to it, so we would fill it in. Would we shade to the left or to the right? So we're going both ways, left and right, yes? So what's a number to the right? 4. is 4 less than or equal to 0? No, so that's a false statement, yes? Okay, let's try negative 4. Is negative 4 less than or equal to 0? Yes. If it makes the statement true, it should be shaded. So we need to shade towards the left, negative 4. So that's what I was talking about earlier with checking points. Because I picked a point that I think is the direction we should shade. 4 made a false statement, so it's not included. It should not be shaded with our x is less than or equal to 0. Negative 4 was, so we shade that direction. We shade towards it. Let's do the other one. X is greater than 4. Well, we know the endpoint is 4, yes? Is it equal to it? No. So it's going to be left open, yes? Then I would agree, then we would shade to the as 5 is greater than 4, we shade that way. And if you're not sure, check points. Check points. Or we could have gone back to the unbounded intervals for each one of those and figured out how they shade. Let's see another one of these. For all real numbers x such that x is less than negative 2 or x is greater than 0 is what we're wanting to graph. We can do this one first. X is less than negative 2. Our endpoint here is negative 2. It would be open. It's not equal to it. Now we need to see, do we shade to the left or to the right? We're thinking left. Is negative 3 less than negative 2? Yes. Now it seems very arbitrary which number I pick to the left of it, and it is. It's literally you're just going to pick a number that is in that zone. So I can pick any number left of it. I could have picked negative 5. I could have picked negative 3,000. It doesn't matter. We're just checking to see, does this number work? I wouldn't pick 3,000 because it's kind of hard to see. I'm just looking to the left or to the right. Because if I wanted to, I could have tried negative 1 to the right of it. Negative 1 is not less than negative 2, so I know it's not included in that statement. Zero, and then we're going to the right. Because 1 is indeed greater than 0. And 5 is greater than 0. It is possible for these two OR statements to actually go towards each other. If they do, we're covering up the whole line. It's everything. Questions on this here? How do we feel about graphing these? Do you want to see one more? Which one? Or both? Both. For all real numbers x such that negative 6 is less than x is less than or equal to negative 2. This seems like it's completely different because if you notice the number line has no numbers, yes? Doesn't matter. What are our endpoints for this? Especially on the homework, this is all I'm expecting. You give me a number line, we get the points. At negative 6, here's one of our endpoints. We have a circle, yes? Would it be opened or closed? Open, because it's not equal to, yes? How about negative 2? And we shade. X is in the middle, so we shade in the middle. And especially on the homework, this is all I'm expecting. I don't need you to give me where it is in location to 0. It does not have to be scaled to size. That's it. We just need to make sure that the smaller numbers are on the left, bigger numbers are on the right. That's set up like a line should be. Questions on 4? Now 5 seems it's way different, yes? No. We have the set of all real numbers x such that x is less than or equal to 0, or x is greater than 10. Let's do the less than or equal to 0 first. Well, I need a point for 0, yes? It would indeed be closed because it is equal to it. Shading left or right? Is x bigger than it or smaller? Smaller. Bigger numbers are to the right. Smaller numbers are to the, so we would want to go to the. And again, even though numbers aren't listed, we know numbers that are smaller than 0, yes? So I could pick -1 and C is -1, less than or equal to 0. It is, so we shade that way. I know I'll need another number at 10. Open or closed? Closed. Are we wanting numbers bigger than 10 or smaller? Bigger, so we're going to shade to the. That's it. Questions on this here? I believe this is the last set that we have, this writing in set builder notation. When we look at what it's saying and what it's describing, we're going to write it out. So the first one is the set of all integers greater than 5. Whenever we write a set, we're always going to start with a brace. X. If we're talking about real numbers, we can put a bar. However, what are we talking about? The set of all integers. So when we talk about integers, we're going to put this E, and then we can use the symbol for integers, which is, it is on the first page. Z with our extra line. Bar. X is an element of the integers, such that. Now we're going to describe it. Greater than 5, yes? Now, if we wanted to, we can say x is greater than 5, but I don't know if we want to write that out every single time. So what we can do is write this as an inequality. Because what are we talking about? We're talking about x, our numbers, yes? And they are what? Greater than. So we would use our greater than what? So we would add it right after the bar. Brace. So we turned the words into an inequality, and we get this here. So the set of all integers, our number group, x is an element of the integers, such that x is greater than 5. We turn that entire sentence into that. Now, I will say this isn't the only way we could write it, especially the textbook. You don't have to write this down. The textbook is going to have us do brace x bar. It's going to be the set of all real numbers every single time. Then it's going to come in and we're going to say x is an integer, and x is greater than 5. I don't know about y'all. I like the first way better. Because if I'm writing x as an integer all the way out, we might as well have left it as a sentence. Because, I mean, we could combine the two. X is an element of the integers, and if it's saying the same thing, we might as well just put it in the first half. Questions on A? Let's look at B. B is again our compound inequality. We have two unbounded intervals, but unfortunately I can't just throw intervals in set builder. It's kind of frustrating. We can't do that. We have to take that up with number theory. Number theory is the whole reason, or gives us all of our reasonings behind how and why we write everything in math the way we do. So what we have to do is we have to convert this back to interval notation and our inequalities. Negative infinity to -1. So we're talking about all the numbers that are less than -1. Because the one that they gave us was negative infinity comma -1, yes? Which one of these four does it match up with? Because we're not looking at the bottom one. The fourth one, yes? So what's taking the place of A? -1, which means we're using this, so we're saying x is less than -1. We keep or. The other one, even though we have two of them, is still unbounded. But this time we have -1 comma infinity, yes? So it's not the fourth one anymore, it's now the second one. And this time A is, well, actually A is still -1, yes? So we're saying x is greater than -1. We kind of get how we changed it from interval to inequalities, yes? Now we need to put it in set builder. Yes? Did it tell us what number types we're talking about? Yes and no. It didn't directly say the set of all real numbers or the set of integers or the set of natural numbers. But by giving us an inequality, it told us it's all real numbers. If it doesn't tell us, we are assuming all real numbers. So to do all real numbers in set builder, it's our brace x bar, the set of all real numbers. There's only one thing this is missing now. The other brace. Because our description is just the converting that from interval to inequalities. The set of all real numbers x such that x is less than or -1 or x is greater than -1. That's it. Questions on this here? I think these are the last two, aren't they? Or ish. Yeah, I'm not too concerned. I mean, we'll look at these two. They're not bad. Negative infinity, comma, -1. This again is our unbounded. But because we have that bracket, we're looking at our x's less than or equal to a, yes? And our a value is -1. For the other one, we're going from 1 to infinity. I see why you're confused. Yeah. I wrote it here correctly. I was referring, that last one was supposed to be here. I knew there was a question. You were wondering why I was circling here and not here. Yeah. No, you're right. It should have been that one. This one should be here, yes? So we're saying that x is greater than 1. And kind of the tricky ones on this is just converting it from an interval to inequality, and then we throw the rest in. Now the next one, we don't have an inequality, so that's kind of nice. Or an interval we have to change to an inequality. However, they did tell us our number group. It is the integers, yes? So x is an element of the integers, such that anytime you see except a number, you're going to like these, because we're saying the set of all integers, all of them except -4. So x cannot be what? So we're saying the set of all integers such that x is not equal to -4. Now it feels like we should be having to say something or specifying what it could be. That first half, the set of x is an element of the integers. X is a part of the integers, so it's all of them but that. Any questions on anything we've done so far? I'm going to hold y'all for 2 seconds. Yeah. If we want to go back over those, we can. We're pretty much done with this lesson, so, okay. This is the assignment. If you do have questions, Monday, not tomorrow, Monday, we will go over those, okay? Or especially if you want to see those, we will go over those too. But I do plan on starting 1-2 tomorrow, or Monday. All right? Yeah. Yep, so the homework I did attach it, that 1-4. So that is the assignment 5 through 14. So, yep. I'm gonna look over your shoulder. So 5 through 14. So 5 and 6, use the braces to list the elements of the set. Both of those are easily writable, or you can set a pattern. You don't have to use set builder. 7 through 14, interval notation. So our braces and brackets and our 2 numbers are 1 number and infinity. That's all we're doing there. 5 through 14. Yep. So 5 all the way to 14. Then 17 through 24. So sketch the graph. So you just need to draw me a number line and sketch what it is. All the way to 24. So 20. 21 through 24. Write the set of numbers as set builder notation. 26 and 27 are the same thing. Okay? I think you should be very comfortable, feel comfortable with pretty much everything but the set builder. Set builder is probably going to be a little hit and miss. If you have questions on the set builder, we will cover them on Monday if you need extra help with those. Okay? As you're working on it this weekend, if you have questions, even if it is, I think I did this right, I'm not sure, and you kind of want more than waiting until Monday, take a picture of it, email me. Because if you did it right, give you a thumbs up. If not, or it needs a little modification, I will fix it and send it back to you.